All right, folks, here's a 2008 Hobie Revo 13 foot. It's a 2008. And one of the key differences with the Mirage drive system in 2008 vessels and earlier was the cam lock, rotating cam locks for the Mirage drives. After 2008, this is a 2011 PA14, get a focus here, they went to these click-and-go mechanisms, which are far superior because the cam locks were problematic, from cracking, leaking, you name it. There were lots of issues, so the engineers at Hobie came up with this design here. So this is a prequel video to a video after this one showing all the details on what I did. So real quick here, I'll try to keep it short and sweet. Gentleman on YouTube did a retrofit buying aftermarket click systems from Lightning Kayaks. So I bought them too because they are almost identical to those, which are stock Hobie. The only difference is the finish, from what I could tell. I put a caliper on the material, it's all the same thickness, yada yada yada. So it's $35 each versus $55 to $60 each, depending on where you buy them. These are the old cowlings that go onto the click system. Of course, I didn't need them, didn't want to use them because I wanted to shore this whole environment up with these teak blocks. So I had some spare teak. I used modeling clay to make an impression, and I did my best to carve them out. I have, again, a post video about all that build. Now, real quick, the difference between the gentleman who posted on YouTube the first retrofit using these in an older Hobie Mirage drive kayak is that he used them stock, used these cowlings with the 2 hex bolts, drilled 2 holes where the 2 holes in a normal click-and-go system exist, but they're different. They're hermetically sealed, so they are pressed in inserts, female brass threaded, or maybe they're stainless threaded. I haven't really looked at them close, but in this case he drilled 2 new holes and put nylock nuts on the underside with washers. I didn't want to drill more holes. Did not want to drill more holes. Also, the stock click-and-go system here, this vertical piece, the place where the drum shaft rests is actually up higher than what you see here. So the stock location sits in these divots with the cam locks. Putting one of these in, retrofitting without doing any modification, brings up your shaft at least a ½ inch. And that is not ideal because it brings the whole drive in the well up ½ inch, and you get collisions with the bottom edge of the opening of the hole here, here, and here. When you pedal, it collides here, here. These 2 spots on either side. So I cut these, lowered them, had a shop TIG weld them, stainless TIG. So now this area right here where my fingernail is at is tangent with the horizontal base. Okay, so I lowered it about 3/8 of an inch. Long or short, I am now 3/16 of an inch higher than the stock, which is acceptable. There's no collision with any of the drive parts, the sprockets or any of that, or fins or mass or anything under the hole. So that's great. Secondly, I didn't want to drill the holes. Like I said, I took these off and I used the teak because I wanted to use the original hardware here and shore this area up. So there it is. That's what I did. I think it's going to work well, and I have a video about more details here, but instead of lifting this dry, because it's hard holding this camera with one hand, you can see here, I'm sorry, I'm not videoing it. You lift that out and it resets itself. So there it is. And then, right, that's just a spare shaft that I actually made from ½ inch stainless as a spare drum shaft. So that's it in a nutshell. Where I'm at now is, because I was weakened so much in this area, and the columns are further weakened. I'm considering using this expensive Loctite 3035 epoxy that sticks to polyethylene, low surface energy plastics. I'm thinking about smearing it all on the underside and on the sides of these teak and the wall here, and then installing it, and then coming back and chasing a bead of it around the top here of the teak to seal this all up and make it a permanent install. The only drawback to that is I'll never be able to take these out to repair it, but I really don't feel like I will need to. I mean, I don't use the kayaks very much. I mean, you know, probably once a month. And so if this permanent install only lasts 3 years on a 2008 kayak, I'm satisfied. But I think it'll outlast the kayak, because the kayak is pretty old. So that's what I did. That's how I did it differently from the guy who posted on YouTube, but it's great that he did, because it really provoked me to move forward to do this modification. So I appreciate him posting that. That's great. The only thing I'm going to have to do, like I did over here already, is just shim this up about 1/8 of an inch so the drive doesn't rock as much. It's nice and sturdy. So that's it. Thanks for watching. Stay tuned if you want to see the details on how I modified these Click-N-Gos and how I made the teak block and all that jazz, if you're interested. But I think this is a solid upgrade for the kayaks that use the old cam locks. I think this is a solid upgrade. Of course, you got to have the tools to do some of the things, and the resources to cut and weld this, and I chose teak. You know, that's probably the best material as far as wood. There are other methods. I was thinking, I was going through maybe making a stainless bracket that wrapped around and came up to the deck here, and then, you know, pop rivet through the vertical or the horizontal part of the deck here. Again, I didn't want additional complexity or holes in the kayak. I think this is going to work great. Thanks for watching. Stay tuned if you want to see further details. Bye. Well, I forgot to show in video the underside here of the teak block. I used 3M 5200, and of course mechanical fastening with the stainless wood screws there, but that's what the underside looks like. And heck, I've been doing so much video of this, maybe I did include it and didn't realize it, but there it is. And then that's where it's going to sit in there. So again, I'm pretty sure what I'm going to do is slather in that good epoxy that sticks to polyethylene all through this area here too. Make sure there's no leaking through this area, and it's a permanent install. But again, that's the teak block and kind of how I carved it out there for the click arm and whatnot. So that's what it looks like on the other underside. And the way I set that actually is I put the marine adhesive, the 3M 5200 on, put the block down on top of it, and then screwed this in. And because that's slow cure, I gave it at least 4 days before I took the assembly out, and that was that. Okay, here's some quick stills. One thing worth pointing out here, some of you may have noticed or are wondering why there's so much carnage in the drive well from welding. You got to be very careful with a hot iron. You get in those tight spaces, you end up burning places that you don't even realize you're burning. But here's some of the build stills for this project. All right, quick shout out to Astro Mechanics in Round Rock. They welded both of these up for me, stainless TIG, for $38 out the door. I cut them because it would have been more if I had them cut it, but there you have it. You can see that where that axle rests now, right there at that point where my middle finger, it's tangent to the base. Okay, so I brought it down 3/8 of an inch. On the underside, of course, when they welded it, there was actually a little more sticking up through here too, and there's interference with the decking. But because you can't tell this, the decking kind of tapers off here and here just a slight bit, and then you've got the original axle point here, which is why I left that little center area there. It rests in there pretty good, so it's gonna go right there. Now what I'm going to do is heat it up and actually that little bit will press into the polyethylene hull in that area, and it'll be a setting method. You know, it'll actually put a divot, a slight divot. It won't go through the hole. It'll be a slight divot, and that'll be my set point for whenever I continue assembling. I used some small wheels here to get this whole surface nice and square and flat. That's this side, and continue with the build. Stay tuned. Hey folks, Roy here. I want to show you what I'm going to do to fix my 2008 Hobie Revo 13 Mirage drive locking mechanism, more commonly known as cam locks, which is the version locking system they implemented on their kayaks all the way through 2008. After that, 2009 and newer, they have the new Click-N-Lock system for the Mirage drives. I have a 2011 PA14, so I have that version there, and it's rock solid. This is a 2008 when I bought these both used 2 years ago. I didn't know much about the difference, but I did find out later that I had an issue with one of the cam columns inside here. But I'm not going to go too far in detail, because if you're here, you know, and you want to stay here, you know all about the cam locks. And there they are sitting there without the hardware though. I took the bolt out. Here's the bolt. Anyway, when I bought these 2 years ago, one of the sides had a cracked cam column. That's the extruded interior portion. And the other side was deformed severely, maybe because the previous owner used these turbo fins, put a lot of torsion and torque on it. I don't know. But I repaired that through a method posted on the Hobie forums. Great method, rock solid. Had to buy this expensive $50 tube of Loctite 3035 epoxy that actually adheres to low surface energy plastics like polyethylene. Well, I made that repair shortly after getting the kayak. Fast forward a year, everything's rock solid except for roughly a year after having it, I discovered a leak and I had a crack. I don't know if this crack was here. You can see that big gash, that big crack there. I think it was a crack that started to form like this one over here, like that one, but on both sides, and water was getting in the hole. So I repaired that, and that lasted 6 months. Then it came back. Repaired that. That lasted 3 months. Then this happened. Repaired that, then that lasted a month and a half. You get my point. Each successive repair didn't last near as long as the previous repair, and now I'm at a point of no return. So I often wondered if the Click-N-Go could be modified and used, retrofitted here in this system. And everything I looked up online up until about 2 months ago, 3 months ago, it was pretty much not possible because of the geometry and this, that, and the other, and I kind of dismissed it until Blue Summit Outdoors posted a video this past March. He did it in an Outback, a 2007 or 8 Outback, and he actually too bought the Lightning Kayaks version of the click mechanism, which this is it in my hand here. This is one side. I think this is the port side. Identical to the Hobie. And I looked at my PA14. Everything's identical. The gauge of the stainless. The only thing is the finish of the stainless looks a little nicer on the Hobie. So I watched this video. I said, hey, I'm going to do it. Let me order these guys. So when I order it, I get these guys in. Of course, I start doing some dry testing, all that, looking at what's going to happen here and how I'm going to get this to mount. What he did is he used these templates and just placed it in here and drilled those 2 holes. There's the Allen hex bolts there with the Allen heads. He just plopped them down in there and then used nuts on the underside with washers, and he went off. He was done. Well, I knew immediately going with this, I'm going to raise that axle, that drum axle, a 1/2 inch. Well, does that matter? I think it does. And here's why. When you set the drive in there, and it's in the default location, so you've got the axle here and it's default. This is where the drive sits. See this mark here? So most of the sprockets protrude beneath the hole, and it operates as stock default. When you bring it up a ½ inch, because of where this seat is, you can see where that seat is. It comes up a ½ inch of where it used to be. Actually, it's hair more, really. But anyway, whenever I test it using shims and I get underneath the kayak hole and I look, the bottom of the hole is here, whereas before it was here, now it's here. And when you operate the drive, where these X's are on the sprockets, and this is where the mast, they call this the stainless mast for the fins, there's collision on the underside of the hole, right here and right here. And you don't get the full swing. So you don't get the full swing. You're not going to be able to tuck the fins up as high as stock. You're also going to get a thud sound when you go to a full stroke, and it may not even be a full stroke. So there's collision. So that's problem number one. Problem number two for me, I don't want to drill 2 new holes here. I don't want to drill any more holes in this damn thing because I'm getting water leak problems. When I'm in this kayak, or my buddy's fishing in this kayak, we're the same load in this kayak, this whole area is full of water all the way up to the top of this cam lock. So I don't want to drill holes. Don't want to do it because I have steel mesh underneath here, stainless steel mesh underneath here. It's weak already, and I've got that PVC cam column fix on both sides here, so there's less room to get a nut on each side here. So I don't want to do that. So I'm going to sand this area flush, prep it. I'm going to seal this up good with whatever means I can and destroy the capability of ever being able to go back to stock cam locks, because I don't give a shit. Gonna not worry about that. The primary goal here is to prep this surface and get it as flush as possible and to seal this. Then I'm going to have a local machine shop weld. Actually, I'm going to cut, but they're going to weld it for me. They're going to stainless TIG it. I'm going to cut where that black line is, and then what they're going to do for $30 is they're going to make this point tangent to this bracket surface here, so that the axle sits down 3/8 of an inch less. So now effectively, instead of a half inch rise, I'm only going to get a 1/16 of an inch rise, or an eighth. I'm sorry, an eighth of an inch rise instead of a ½ inch, or 3/16. I can't remember, but doing an estimate here, this is where it's going to, the bottom of the hole will be, and I no longer get collision here and here. So that's one of the major things I'm going to do, is have that where it's lowered. And you know, there's going to be a little bit of a lip on the underside, but I think it's going to clear. And if not, I can grind some and or heat it up. And when I set this down in here, it'll just deform a bit the decking so that it sits flat. I'm also going to use 5/4 bore teak. And if I can explain this, what I'm going to do is I'm going to make a teak block, and it's going to be shaped this entire area. And I'm going to use 3M5200 to stick it onto this surface here. I'm going to use a Forstner bit and a larger drill bit to drill an access hole. And then when I place this, make sure that it's not too far inboard, too far out. And I'm going to carve that teak to where I get nice contact all the way around this vertical bulkhead area. And I'm going to have a hole access for the original bolt. So I'm going to have the original bolt in there for mechanical fastening. I'm going to put a lot of this adhesive all on the underside here and glob it and plop it down in here. And then I'm going to have adhesive all on the perimeter of this block, this teak block. And then I'm going to screw that bolt down in here and lock it into place. Make sure it's in the right position. Lock it in place. This is not on the right side, by the way. This is the one for this side, the starboard side. But anyway, and then I'm going to set it up, and that's it. I don't think I'm going to need any more mechanical fastening, because even though it's one single point, you would think it would rotate. If I make that block shaped tight enough with this adhesive, it's not going to go anywhere, not going to move. If I feel like I need to do something later, I can certainly put a cross brace over the top here, and then shim it through this area and lock it down from the top. Again, I don't want to drill more holes. But that's the idea. Blue Summit Outdoors, a great idea. I'm going to mention them in the video when I post this, but I need to lower that. I don't like that 1/2 inch rise, because like I said, you get collision here. That's bad. So I am going to cut this, send it over to the local shop that's going to do the stainless TIG it up. I'm going to use modeling clay maybe to get a profile for this cavity here, so that I can cut out this 5/4 teak. 5/4 teak will be mechanically fastened through these holes here, and some stainless wood screws, countersunk maybe, or whatever. You know, it is countersunk already on the bottom, so I can use the stock screws that it came with. But with 3M 5200, that stuff is crazy strong with stainless and teak. If anyone knows anything about teak, metal, or fiberglass, 3M 5200 to metal or wood, it's a fantastic marine sealant and adhesive. It's permanent. And that's it. That's what I'm going to do. So next video will be the final result. I will add it to this video and I will publish it, and I will let you know how it goes. Again, this is to retrofit the click mechanism for the Hobie Mirage drive in an older Hobie that uses the cam column locks, which I am now done with because of the situation of my drive well. So I hope this works. Stay tuned for the rest. Thanks. Bye.